Assalamualaikum and good day everyone. So now we are going to learn chapter 4, analysis of variance. First we look at the content for your chapter 4. 4.1 we are going to learn the introduction to the ANOVA. 4.2 is the one-way ANOVA. 4.3 two-way ANOVA, and 4.4 we will solve ANOVA using the Excel. When we finish this chapter, you should be able to use the one-way ANOVA to determine if there is a significant difference among 3 or more means, and then you will be able to use the two-way ANOVA to determine if there is an effect of interaction between two factors in an experiment. First, we go to the introduction of the ANOVA. So in this subtopic, you should know to describe the purpose of ANOVA, and then you should know to state the assumptions that underline the ANOVA, and 3, you should know to do the hypothesis testing procedure to solve the ANOVA problem. The purpose of ANOVA is to compare the difference of more than two population means. ANOVA is also known as factorial experiments. ANOVA allows us to use sample data to see if the values of more than two population means are likely to be different from each other. In ANOVA, we have two types of ANOVA. One-way ANOVA, when we have one factor only in our experiment, and two-way ANOVA when we have two factors in our experiments. So always remember, one-way ANOVA, one factor, two-way ANOVA, two factors. This table shows you the difference between hypothesis testing for difference mean and ANOVA. This is the hypothesis testing. The first row is for hypothesis testing. The second row for the one-way ANOVA, and the third row is for the two-way ANOVA. So as you can see from our previous lesson in chapter 3, hypothesis testing, you know that you can compare only two samples. But when you have more than two samples, you cannot use hypothesis testing. That's when we use one-way ANOVA, because one-way ANOVA can deal with more than two samples. Two-way ANOVA, we will use two-way ANOVA when you have two factors in your experiment, because one-way ANOVA only can deal with one factor. Two-way ANOVA can deal with two factors in your experiment. This flowchart shows you the step to solve the ANOVA problem. Step number 1, formulate the hypothesis. Read the question, construct your hypothesis, and then identify which one is the claim between the H0 and H1. Step number 2, construct and complete your ANOVA table. Okay, make sure your ANOVA table is complete with all the values, and then make sure all the values is correct. Step number 3, find your critical value, find your F alpha. Step number 4, compare your F test with your F alpha. You will reject H0 if your F test is larger than your F alpha. The decision is reject H0. And step number 5, make your conclusion from your decision in step 4.